Is a video to show you how to use the solver function or the solver capability on the TI-84. So the solver is really handy for solving equations where you don't necessarily need to show all of your working and where you don't need an exact answer. For example, you can give an answer to three significant figures in one decimal place. It's really good for anything where you need to you've got a complicated, lengthy equation, yet you're trying to reverse something, find the missing bit, and you're not overly comfortable with all the algebra steps involved to get to there, or it's just a really complicated, messy equation. Having said that, you can use them to solve a simple equation as you like, really, a simple an equation as you like. So you can solve something like 2x minus 7 equals 0, for example, or something even simpler. Or you can use it for lots of trigonometric applications. Something like this, 5 over sine x equals 7 over sine 40 is a complicated equation to rearrange. A lot of people aren't comfortable with that. So I'm going to show you a few examples where you can use the solver. And another reason why it might be a really good idea, if you are comfortable with the algebra, but you want to check your answer. Now, obviously, there is a time trade-off there, but to check that what you did is right, the solver would be really handy too. So first example, here is a basic right angle triangle. So you've got x is the side you're trying to find. You've got 5 centimeters, you've got a right angle, and you've got 38 degrees. So the solver's not going to solve this for you, but once you set up the equation, it's really good from there. So hopefully you know enough about right angle trigonometry to know this is HOA. The O and the A are involved. That means tan. So that means that tan 38 equals 5 over x. Now, unfortunately, this isn't something you can type into the solver. On a Casio, you can. On the TI solver, you need 0 to be one of the sides. So you need something to equal 0. So you really need another step in this before you go to the solver and make one of these sides 0 by subtracting one of them. So I'm going to write 0 equals 5 over x minus tan 38. So you've just subtracted tan 38 from both sides. And if you use this solver regularly, you will get used to this. It's the same rearrangement every time, so it's not too bad, but it is a bit of a pain. So now we can go to the solver. So the solver is found in, you use the math button and then you go up. So we go up and it's the first thing you come to. So solver is there. Before I do this, given that it's a trigonometry thing, in fact, before you even start an exam or really any exercise, certainly up to IGCSE level, you should always make sure you're in degree mode. So I'm going to press mode and I can see I'm not in degree mode. So I need to make sure that radian says degree. So angle needs to be in degree. So then I'm going to quit and I'm going to go back to my solver. So math and up. And I'm going to pick 0 equals, so 5 divided by x. So x is here. Minus tan 38. Tan 38, I'm going to close the bracket. So that's the equation. So 0 equals 5 over x minus tan 38. Press enter. Now, here you have an option to guess a value of x. I'm not going to bother. I'm just going to leave that. This bound in here, which we will use later, that's telling you it's like the domain of all the x's that could be. So here it goes from minus 1 times 10 to the 99. So that's a 1 and 99 zeros. It's negative. So it's a really big, really big negative number. And it goes all the way up to the same number but positive. So basically, for any application that you're likely to do, this covers all real numbers. You can change that and we will change it later. But to actually do this solve, you need to make sure you're in this area here on the X bit, and you can see solve is written down here in green. So to get to anything green, you need to press the alpha button and I press enter. And you can see here it's doing something, it's loading, it's thinking about it. So it might be that it could be a BidMass problem in here. So I'm going to, I'm going to try 0 equals 5, I'm going to put that 5 over x in a bracket. So 5 divided by x minus tan 38. Like that, and I'm going to try again. So alpha solve. Okay, and it still doesn't like it. So what I'm going to do this time is I'm going to change the domain. So I'm going to go back to the solver. I'm going to go up into the solver, and I am going to look at these bounds. Now I know well, x is definitely positive, so I guess we could change this minus 1 times 10 to the 99 to just a 0 and delete some stuff. And then realistically, I don't know, let's go up to maximum of 100, something like that, and see if something good happens now. So go up and alpha and solve. And finally, it's given us an answer. So the Casio doesn't have all these clunky problems, but unfortunately on a TI, this is the only exam legal solver that you're going to get, unfortunately. So if you're going to use it, you need to get used to its difficulties. So anyway, x is 6.39971. So that is 6.40 centimeters to 3 significant figures. Right, another example. Okay, here we have a cone. So this is telling you, so the question might say, here is a cone. It has a perpendicular height of 10 centimeters, a radius of r centimeters, and the volume of the cone is 230 centimeters cubed. And it would say, find the value of r, right? So hopefully you know enough about cones, or you know enough to look at the formula sheet and see that the volume equals 1/3 times pi r squared times h. So 1/3 of the base area, the circle, times the height. And that should lead you to get to here. That looks like that. Unfortunately, with a TI, you need to make the thing equal 0. So remember, you can have either one of these sides 0. So it's much easier to take the 230 away from both sides than all of that. So the next line would be, so 1/3 times pi times r squared times 10 minus 230 equals 0. And that is what's going to go into the solver. So to get onto here, I'm just going to delete all of that. And then for the 1/3, I'm going to put in brackets 1/3. So 1 divided by 3. What you don't want to get that 3 mixed up. Is it multiplying? Is it dividing it? If you use brackets, you will know. So 1/3 times pi. So where is pi? Pi is over here in blue. Times r squared. So we don't have an r, but we have an x. So x squared times 10 minus 230. So hopefully that will be all right. I'm going to try with this big bound again. Hopefully it works. If it doesn't, then I'll come back and change the bound. But I'm just going to press solve. So alpha solve. And actually, it's gone straight to an answer. So this equation was a lot better. So it's telling me that x is 4.69. So r, the radius to 3 significant figures, is 4.69 centimeters. And the solver's gone there in one step. So if you get the hang of it, it did still save us some time, I think. Okay, a third example here, we have a triangle. It is not a right angled triangle, it's another trigonometry example. Hopefully you know enough to label the side you want little a, maybe call the other two little b and little c. Say that big A, the angle, is opposite little a. And then you might recognize that you have two sides and a trapped angle, included angle between them, and you need the other side. So hopefully you know that a squared equals b squared plus c squared minus 2bc cos a. That is the cosine rule. So if you don't know that, you are struggling, but that is the line. So a squared, so x squared equals 10 squared plus 13 squared minus 2 times 10 times 13 times cos 41. On a Casio, that will be fine. On a TI, you're going to have to make it equal 0. The easiest way to do that is to move the x squared, subtract. So I'm going to write 0 equals 10 squared plus 13 squared minus 2 times 10 times cos 41 minus x squared. That is what goes into the solver. Okay, so we've got the solver. We're just going to go up, and I'm going to delete everything. So 0 equals 10 squared plus 13 squared minus 2 times 10 times 13 times cos 41, and all of that minus x squared. Okay, so, and I'm just going to see if it works. So alpha solve, and it does. Fantastic. So x equals 8.53 centimeters to three significant figures. Okay, here is an example involving a sector. Now, all of these examples are shape-based, but they certainly don't need to be. I'm thinking something compound interest, percentages, anything what is repeated percentage change, and you need to do something involving a reversibility. Could work really well for solvers. It certainly doesn't need to be limited to shapes by any means. Anyway, here you go. This question might say, here is a sector with radius 11, arc length 10, find the angle x. So hopefully you know enough about arc length to know that they're related to circumference of a circle. Know that circumference of a circle is 2 pi r, which I think is in the formula sheet. You should know that this sector is like a part of a circle. It's a fraction of a circle, and the fraction is the angle over 360. So you should know that the formula for arc length is x over 360 times 2 times pi times radius. So that would enable you to form this equation. So x over 360 times 2 times pi times 11, the radius, equals 10, which is the given arc length. With it being a TI, you need to subtract the 10 and leave it as x over 360 times 2 times pi times 11 minus 10 equals 0. That goes into the solver. So up and delete everything. Can I just clear? I could just clear. So x over 360, I'm going to write x divided by 360 in a bracket. X divided by 360 times 2 times pi times 11 minus 10. So 0 equals x over 360 times 2 times pi times 11 minus 10. I have not written the minus 10. Okay, there we go. So see if it works first time. It did. Fantastic. So we have x equals 52.1 degrees. So if you're given an angle, unless told to do otherwise, you should give it to one decimal place. So 52.1 degrees. Final example, find the obtuse angle ABC. So this is probably the hardest question in there, because it's a way that the solver could lead you to the wrong answer. So this word obtuse is really the key. That's what I'm talking about, really. So we're looking for the angle ABC. So if we go from A to B to C, it's this angle. We want the angle at point B. So hopefully you know enough about triangles to know you've got the 7 centimeters opposite the angle that we want, and you've got another pair, the 5 is opposite the 40. So when you've got two pairs of opposite sides and angles, so non-included angles, non-trapped opposite sides and angles, this is the sine rule, which is A over sine A equals B over sine B equals C over sine C, and so on. So basically, that should enable you to form an equation just like this. So knowing that they're opposites, so sine 7 over the sine of the angle opposite the 7, I'm calling that x, which could just as well say ABC, equals 5 over sine of the angle opposite 5, which is 40. So with it being a TI, we need to subtract one of these from both sides to make it equal 0. It doesn't matter which one. So I'm going to write 0 equals 5 over sine 40 minus 7 over sine x. So that's the equation that goes into the solver. Okay, so in here I'm going to type 0 equals 5 divided by sine 40. I'm going to put that all in a bracket. 5 divided by sine 40, close the bracket, minus 7 divided by sine x. So sine x, close that bracket, close the other bracket. The equation looks so 5 over sine 40, 5 divided by sine 40 minus 7 divided by sine x. That's set up. I'm going to change these bounds. So say I know this, I'm looking for an angle, so it's in a triangle. So smallest angle in a triangle could be a bit more than 0, and the largest angle in a triangle could be a bit more than 180. Now, I'm going to refine this guess soon, but for the purposes of demonstrating how you can misuse a solver, I'm going to use this as my bound. So when I want to solve, if I've been on bound, I need to go back up here before I press solve. So now we've got an answer. So x equals 64.14 degrees. Now, it is absolutely true that 5 over sine 40 minus 7 over sine 64.145274430 and so on equals 0. That is true. However, 64.145274430 degrees is not obtuse. So we need an obtuse angle. Remember, this is an ambiguous case sine question. So basically, we're looking for the obtuse angle where 5 over sine 40 is equal to 7 over sine x. There will be an obtuse angle where that is true as well. So I'm going to go 90 right, so I'm going to guess something that's actually in the range. So let's guess, say 100 degrees, and then alpha solve, and it thinks for a bit, and there we go. So x equals 115.9 degrees to 1 decimal place, and that now is correct. So, and actually, to be fair, if you could see this question, calculator paper, you can form the first equation and then you can get to the answer. You're very unlikely to miss any other marks. I think you'd probably get all of them, unless you made a rounding error or something like that. So I think the solver for this, a question like this, could be really, really useful. So hopefully you can do a lot of practice and get used to solvers, and it's another tool in your armory for exams and for classwork and going on to the IB.